The biggest crater on the moon is much bigger than we ever realized. The moon bears its history on its skin. Earth's only permanent natural satellite is scored and scarred with billions of years worth of cratering, a record of constant bombardment. The biggest and oldest of these scars is a monster crater, one of the largest not just on the moon but in the entire solar system. The South Pole Aitken Basin covers nearly a quarter of the moon's surface, with a diameter of some 2,500 kilometers, that's 1,550 miles. It's not easy to study the South Pole Aitken Basin. It's over 4 billion years old and huge. In addition, time and subsequent impacts have done much to obscure it, but new research suggests that the ancient gargantuan crater may not have formed the way we thought and may be much bigger than previous studies suggest, a discovery that has exciting implications for future lunar missions to the basin. It's challenging to study the South Pole Aitken Basin holistically due to its sheer enormousness, which is why scientists are still trying to learn its shape and size, says geologist Hans Bernhardt of the University of Maryland. He says our work challenges many existing ideas about how the massive impact occurred and distributed materials, but we're now a step closer to better understanding the moon's early history and evolution over time. Previous work on the South Pole Aitken Basin found that the impact was created by an oblique collision with a large object, leaving behind a crater shaped more like an oval than a circle. Under this model, the debris would have sprayed predominantly in one direction, away from the lunar South Pole. Bernhardt and his colleagues wanted to investigate the way this impact played out by studying the geological features on the surface of the moon today. NASA's Lunar Reconnaissance Orbiter has been circling the moon since 2009, mapping its surface and collecting a wealth of lunar geology data. The research focused on more than 200 mountain features scattered around the outskirts of the basin that the team thought may be remnants of the crater rim. When the cataloging and the mapping was complete, however, the shape formed by these features was far more circular than the researchers expected it to be. Impact gouges out materials from deep under the lunar crust and sprays them over the surface. Because the moon does not experience erosion from geological or atmospheric weather processes that obscure impact event evidence here on Earth, those materials should still be there. A rounder, more circular shape indicates that an object struck the moon's surface at a more vertical angle, possibly similar to dropping a rock against straight down onto the ground, Bernhardt says. This circular impact implies that debris from the impact is more equally distributed around it than was originally thought, which means that Artemis astronauts or robots in the South Pole region may be able to closely study rocks from deep within the moon's mantle or crust, materials that are typically impossible for us to access. Those materials could give us new insights into how the moon formed, a process that is shrouded in mystery and the topic of much healthy speculation. The current leading explanation is that Earth's satellite is a chunk of planet that broke off during a giant early solar system impact, but alternatives include coalescence from a cloud of debris or gravitational capture. A more vertical angle of approach for the impactor could explain other strange features of the basin. For example, measurements of the moon's gravity around the region suggest that under the giant crater, the crust of the moon is much higher density than its surroundings. A possible explanation for this is the presence of a dense chunk of asteroid buried therein. Having direct access to the treasure trove of minerals from early in the moon's history could help answer such questions. Bernhardt says one of the most exciting implications of our research is how it is applicable to missions on the moon and beyond. Astronauts exploring the lunar South Pole might have easier access to ancient lunar materials that could help us understand how the moon and our solar system came to be. This was published in Earth and Planetary Science Letters. It's by Michelle Starr and Science Alert. Please leave your comments, and thank you for your support. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.